Hello and welcome to this Electrical Principles training video. This video is designed to be used in conjunction with the worksheet. You'll find a link to that worksheet in the description below, so please click on the link and download that and have a look at that before you watch the rest of the video. What we're going to do is we're going to answer the second question from that worksheet, and on the worksheet you'll see laid out the question that we've got here. And what we're being asked to do for this question is to calculate the illumination levels at point P1 and at point P2. Now this is a slightly trickier question because, as you can see, we've got two light sources, one here and one here, and we've got two lighting points to calculate as well. So there's quite a bit of calculation work that needs to go into this calculation. So the first thing I do on this question is I'd make sure exactly which light fitting I'm talking about, that I know which one I'm talking about. So I would label these up first of all. I'd call this one maybe IA or something like that. So that gives me my luminous intensity at that point is 1500 candelas, and I'd call this one I with a B in the subscript to tell me that my luminous intensity at this point is 1200 candelas. Now at first glance this may look a little bit overwhelming because we've got to figure out how much light at this point is coming from there, and then we've got to do the same, so it looks like there's a lot of calculations to do. So what I would do is, first of all, I'd break this down into almost two questions. So I'd start off by thinking, well, I've got a light point here and here, and I want to figure out what the light level is at that point there. So I'd just sketch that out again and just show myself exactly what I'm trying to figure out. So immediately that starts to look a little bit friendlier. So we've got our luminous intensity at source A, which is 1500 candelas. And then we've got our luminous intensity at position B, which is 1200 candelas. And then we're trying to figure out what the light level is at point 1. The other important thing on here to note is the measurements that we've got. So this is 2.4 meters. These light fittings are mounted 2.4 meters off the ground. Because we don't have another measurement here, we can assume that that's mounted at 2.4 meters, the same as that one there. So let's have a look at what the light level at this point here is going to be. We'll bring over our 1.5 meter distance there and our 2.2 meter distance there, and just put 2.4 meters there as well. So I do that just to help me kind of visualize what's going on. So what I would do now is I would look at this and think, right, I need to figure out what the illumination level at point P1 is going to be, and there's going to be two things that contribute to that. The first thing that's going to contribute to that is the light source A. So I want to know what is the illuminance level at point P1 that's being caused by light source A. So I'd just do that. So the illuminance at position 1 from light source A, that's what I'd be looking at there. And in order to calculate that, we need to use the following formula. We need to say that I multiplied by the cosine of theta divided by d squared. So if any of this is looking unfamiliar to you, then please go back and watch the previous videos that I've done on lighting, because it's going to help you to understand what this capital E means, what the I means, and all those different things. So please go back and watch that video if you've not already done so. Now at this point, the temptation is to start putting all the numbers in. So we'll say we've got I, well, we know what I is at position A. It's 1500 candelas. And just to avoid confusing yourself, you could even put a little A there in the subscript, just so you remember that that's the one that you're dealing with. And then we're going to multiply this by cos theta. Well, what's this cos theta? Where's that coming from? Well, cos theta is the angle that is formed here. So it's the angle there, which is going to affect the amount of light that hits point P1 there. So we don't yet know what that angle is. We need to figure that out. We also don't know what this value for d squared is, or what the value for d will be. D is the distance from the light source to the point that we're calculating. So it's this distance here, and we don't know that yet. So we need to find two pieces of information to put into here. Now, fortunately, using a little bit of Pythagoras and a little bit of trigonometry, we're well able to do that. So let's do that first. Let's figure out what this side here is going to be. So we've got a right angled triangle. So that's a right angled triangle. We could label these sides up A, B, and C. And we know from Pythagoras that a squared plus b squared is equal to c squared, like that. So if we want to figure out what the value of c is going to be, the formula will look like this. C is equal to the square root of a squared plus b squared. So now we can put our numbers in. We've got the square root of 2.4 squared plus 1.5 squared. So we can put that into our calculator and come out with the answer. So let's volley that into the calculator now. We've got the square root of 2.4 squared plus 1.5 squared, and that's going to give us an answer of 2.83 meters. So we'll round that off to 2 decimal places, 2.83 meters. So that's what we're looking at there. So the distance from this light source to this point here is 2.83 meters. Right, so that's great. So now we know actually what the distance from the light source to the point that we're calculating is. It's 2.83. So we can put that into our illumination calculation. So we can put that in here, 2.83 squared. We then need to figure out what the value for the cosine of theta is going to be. Now again, if you haven't already watched my videos on trigonometry, then please do so, because it will help you to understand what's about to happen next. We're interested in this angle here, and we want to know what the cosine of that angle is. So we know from our trigonometry that the cosine of theta is equal to the adjacent divided by the hypotenuse. And the adjacent divided by the hypotenuse, which side are we talking about here? Well, we're interested in this angle. So this side here, which is next to the angle, is the adjacent, and the long side is the hypotenuse. So we're going to do 2.4 divided by 2.83, and 2.4 divided by 2.83 is going to give us our cosine value. So we'll put that into the calculator next. 2.4 divided by 2.83, and that gives us a value of 0.848 we'll go for. 3 decimal places is normally a reasonable value to round off for when you're doing anything involving trigonometry. So now we know the cosine of theta is 0.848. So we'll stick that into our illuminance calculation. So we've got 0.48 is the value that we're going to put in there now. So we'll stick that there, 0.848. And we're now in a position where we can figure out what the illuminance at this point here is that's being caused by light source A. So we've just got to do 1,500 times by 0.848, and then we're going to divide that by 2.83 squared. And that's going to give us a value of 158.82. So that's 158.82. And of course we're measuring illuminance, and that is measured in lux. So we put LX on the end there. So that's the first of really 4 calculations that we're going to have to do in order to figure out all of the answer to this question. What is the illuminance at point P1 and what's the illuminance at point P2? What we'll do now is we'll figure out what the illuminance is at point P1 that's being caused by light source B. So really what we're going to do now is just a repetition of what we've done already. So we're going to figure out what is the illuminance level at point 1 that is being caused by the light source B there. So we're going to put in our same formula, except we're going to be interested in light source B. We're going to times that by the cosine of theta, and we're going to divide that by d squared. And really we just need to go through exactly the same process again. We don't know what the cosine of theta is yet, and we don't know what the distance is going to be from the light source to the point. So we'll figure it out. So this is hopefully reasonably straightforward and simple. All we've got to do is acknowledge that buried in this drawing, just here, there is a right angled triangle. And that right angled triangle has sides, which again we can call A, B, and C, and we want to know the length of side C. So it's just a matter of doing some Pythagoras again. So we say that A squared plus B squared is equal to C squared, and that's going to give us our answer once we've transposed it to say that C is equal to the square root of A squared plus B squared. So we now put this into our calculation. We've got the square root of A, which is 2.4. We're going to square that. And then we're going to add on to that b squared, which is 2.2 squared. So we've got 2.4 squared plus 2.2 squared and then square rooted. And we're going to figure out what the answer to that is. So the square root of 2.4 squared plus 2.2 squared gives us a value of 3.26 meters, we'll go with there. So 3.26 meters. There we go. So now we know what the distance from light source B to point 1 is, and we know that that value is 3.26 meters. So we'll be able to put that into our calculation in a minute. Now let's figure out what the cosine of this angle is going to be. So once again, we're interested in this angle here and this angle here. Again, we're going to call that theta. We could probably label these up differently if we weren't going through the process one thing at a time, but we know what the angle we're discussing at the moment. So we're going to say that the cosine of theta is equal to the adjacent over the hypotenuse again. So the cosine of theta is equal to the adjacent over the hypotenuse, which is equal to, in this case, the adjacent, the side next to the angle, is 2.4. And the hypotenuse, which is this long side here, we just calculated was 3.26. So we're going to put that into our calculators now. 2.4 divided by 3.26 gives us a cosine value of 0.736. 0.736. So that means we can now complete this calculation. We can now go back to our original calculation here, which is I times cos theta over d squared, and we can put all these numbers in. So we can say that we've got the value for IB, which is light source B here, 1,200 multiplied by the cosine of theta, which we've figured out is 0.736, divided by the distance squared, and the distance was 3.26. So we've got 3.26 squared. So let's put this into our calculators, 1,200 multiplied by 0.736, and put that over 3.26 squared. And that gives us a total of 83.1 lux. So there we go. We can see now what the illumination level at point P1 is that's being caused by light source B. So to figure out what the total illuminance is at point P1, we've simply just got to add those values together. So the total illuminance at point P1 will be the illuminance at point P1 from light source A added to the illuminance at point P1 from light source B. So that means we just basically add those values together. So we're just going to do 158.82, 158.82, and we're going to add to that 83.1 lux. So we add 83.1 lux. So we'll do that calculation, 158.82 plus 83.1. And that is going to give us a value of 241.92. So the total illumination level at point P1 is 241.92 lux. So now all we've got to do is repeat this process to figure out what the illuminance level at point P2 is. So now we've figured out what the illuminance level at point P1 is, we'll move on and figure out what the illuminance at point P2 is. So here, again, just do a little sketch of the drawing, so try and remove as many of these lines as possible. And if we look at this, we can see that we've got a light source up here that has a value of 1,200 candelas. And that is shining down onto point P2 here. So that's nice. That means that we've got a nice, easy calculation to do there. We've also got a light source over here, which is light source A, and that has a luminous intensity of 1,500 candelas. This light source is shining directly down on here, and this light source is shining like that, except in a straight line. So that's what we're looking at there. We'll just kick the values onto there. So that's 2.4 meters. This here is 2.4 meters high as well. And now we will need to know at some point the distance from that light source over to here horizontally. So that's just that value added to that value. So this will be 3.7 meters. So the distance from here to here will be 3.7 meters. So again, let's have a look at this. We need to figure out what the total illuminances. So we'll start off by saying what's the illuminance at point P2 that's caused by light A. We'll start with light position A. So we just use the same formula that we used last time. We've got I multiplied by the cosine of theta divided by d squared. So here we've got light source A is the one that we're interested in. Start putting the numbers in. 1,500 times by, we don't know what the cosine of theta is yet, divided by, we don't know what the value for d is yet. However, we can figure it out because again, if we look at what we've got here, we have got a right angled triangle with an angle up here, and this is the angle that we're going to be interested in, so we'll label that up theta for a moment. And then here we've got side A, side B, and side C. So in order to figure out what the distance from the light source to the point that we're illuminating is going to be, we will do a little bit of Pythagoras again. We'll say that a squared plus b squared is equal to c squared. And when we transpose that, we know that c is equal to the square root of a squared plus b squared. So let's kick the numbers in. We've got the square root of 2.4 squared plus 3.7 squared. And we can now put that into the calculator and figure out what the answer to that is going to be. So we've got 2.4 squared plus 3.7 squared. And of course, we're going to square root the answer to that. So the total answer once square rooted is 4.41. So the distance here is going to be 4.41 meters. So this value here, 4.41 meters. So that's all good. We've got a distance from point A to this point here that we're calculating the value of the illuminance at, and we've got 4.41 meters. So that's all good. We can now put that into the bottom of our formula, 4.41. And of course, on this formula, we square that bottom number due to the use of the inverse square law. Again, watch a different video for that if you don't know what that is. What we're then going to do is we're going to look at figuring out what the cosine of this angle theta is going to be. So we say that the cosine of theta is equal to the adjacent divided by the hypotenuse. Once again, we're interested in this angle. So this is the adjacent because it's next to the angle, and this is the hypotenuse because it's the long side. So we're going to say that that is equal to 2.4 divided by 4.41. And when we do that calculation, 2.4 divided by 4.41, we come out with an answer of 0.544. So that's 0.544. So there we go. So there's our cosine value, which we can now stick into our illuminance calculation, 0.544. Okay, so we've got all the numbers we need. We can now perform this calculation and figure out what the illuminance is at this point here being caused by this light fitting here. So let's put that into the calculator. 1,500 times by 0.544, and then we're going to divide that by 4.41 squared. And that gives us 41.95 we've come out with there, 41.95. And rounded off, that will be 41.96. So to two decimal places, that's 41.96 lux. And now, all that remains is we need to figure out what the illuminance is at this point here being caused by this light fitting. Now, after all that maths we've done, after all that Pythagoras and trigonometry, this is just a nice wind down to the calculation, like slipping into a nice hot bath after a hard day's work. So what we're going to say here is that the illuminance at point 2 that's caused by light source B is going to be I divided by d squared. We've managed to get rid of the cosine of theta because actually there is no angle here, this is just vertical. You could actually argue that the angle is 0 degrees, and what's quite interesting about that is the cosine of theta is 1. So if we were to put times 1 on the top of this, it would make no difference to the outcome of our answer. I love when maths works so beautifully. So we're going to say then we've got light source B, so we need this value, 1,200 divided by the distance squared, and the distance is simply the distance from the light source to the point that we're illuminating. So that's 2.4 squared. So we've got 1,200 divided by 2.4 squared. And that gives us a total answer of 208.3 lux. So the illuminance level at point 2 caused by light source B is 208.3 lux. Once again, the final thing that we've got to do, just for the sake of completing this question correctly and showing the right answer, is to figure out what the illuminance is at point P2 in total. So we'll take the illuminance level at point P2 from light source A, and we'll add it to the illuminance from at point 2 from light source B. So we put our numbers in here. So we've got this number here, 41.96, 41.96, and we're going to add to that 208.3. So that's 208.3. So let's do that calculation, 41.96, and we're going to add to that 208.3, and that brings us to a total of 250.26. So now we know that the illuminance level at position 2 is 250.26 lux. And that was the answer that we were trying to get to. So all that remains in this video is to say, thank you very much for watching.